Okay, ladies and gentlemen out there in pre-calc, we're going to look at composition of functions next. Another thing you probably learned a little bit about in college algebra. So this is the general way this looks. We use this open circle. Looks like it spells fog. So we do that, and really what it means is you just plug the function g into the variables of the function f. Okay, and then one of the things we'll talk about is whenever you do the composition backwards, it does not necessarily work. So it's not like if you do 2 times 3, you also 3 times 2. We call that a commutative property, but there is no commutative property for composition of functions. So a good way to begin to look at this is if you have a table. This has x values. It has a row for f of x. It has a row for g of x. So if we're finding f of negative 3, we just look at where x is negative 3. We locate f in that row, so that would be 2. If we want to find g of 1, we locate 1. Go to the row for g. That would give you negative 2. So begin just by knowing how to look these things up. Okay, when you do a function composition, the best way to write this is f with a bracket g of negative 3. And what we have to do first is we have to figure out what g of negative 3 is. So I go to negative 3, I look up g of negative 3, I get 2. So now I'm going to have f of 2. Now I go to 2 and look up f of 2, so I'll get 1. So we're just kind of working from right to left. Okay, the next one, I'm going to start by doing f of negative 3. So f of negative 3 is 2. And then what this means is g composed of f of negative 3 can be written as g of f of negative 3. We already looked up f of negative 3 as 2, so we have g of 2. If you look at g of 2, that's going to give you negative 4. Okay, so it's just sort of a matter of looking up the information in the table from right to left. Okay, next problem. Start with g of 1. Look up g of 1. Here's 1. G of 1 is negative 2. So what we're going to do is we're going to do f of g of 1, which is f of negative 2. So we worked out g of 1, and then we look up f of negative 2, which is 3. Okay. All right, next one. Start with the function on the right, f of 4. Look that up in the table. Here's 4. F of 4 is negative 1. So we end up doing g bracket f of 4. So that will be g of negative 1. And then we look that up. That's equal to 2. Okay. Now you can also do a function within itself. You can compose a function with itself. If you look up f of 0, that's 3. So what we're doing in this problem when we do f composed of f composed of f of 0, we end up doing this. We do f of 0. But we just worked out that f of 0 is 3, so ultimately we do f of 3. And f of 3, look at the table, that's equal to 0. Okay, so that's how you would use a table to find a composition. It's a good way to start. Okay, so what I'm going to do is go to the next page, and I'm going to have you guys go ahead and do these problems. Just go ahead and pause the video right now, and when you're ready to check, resume. Okay, so the answers should, number 1, 4, number 2, negative 4, number 3, 4, number 4, 3, 5, 0, and number 6 is 4. If you made any mistakes, correct it. But again, the key to me whenever you're doing these problems is, writing your function composition. This is kind of the key step right there. Okay, then that tells you how to evaluate that. Okay, next thing we'll do is go down the bottom of the page, and we're just going to do the same thing with a graph. So in this particular problem, g of x is the function in red, and f of x is the function that's in blue. So if we do f of negative 2, locate that point, that will have a y value of 0. Okay, now we're going to do function composition. So on this first one, start by rewriting it as f bracket g of negative 1. Then look up g of negative 1. Okay, here's negative 1. G of negative 1 has a y value of negative 3. So we have f of negative 3. So that means go to negative 3, which is here. Look at that point on the graph. Give the y value. So that's equal to 1. Okay. Next one, write this as g bracket f of negative 2. Look up f of negative 2. F of negative 2 is 0. So you have g of 0. Remember, you're giving the y value when you look up the function. And then g of 0, let's see, here's 0. You're down here at negative 4. So the answer to that problem is going to be negative 4. Okay, and the last one here, we're going to write this as g bracket g of, not f of 0, g of 0. Okay, so what we'll do on here is just go ahead and look up g of 0. So when at 0, we're at this point, so that's negative 4. So you'd really have g of negative 4. So now look at, here's negative 4, so you're at that point, so that would be equal to a y value of 0. Okay, so really it's the same thing as doing the table, but you're getting the function value not from a table, you're getting it basically from a graph. Okay, all right, so next page, have you all do some problems. Go ahead and do these 4 problems using this graph. And f of x is kind of the sort of an orange, and g of x is kind of a blue. So pause the video. Okay, so you want to go ahead and look at these. The last one you just sort of had to estimate, because when you do f of 0, that's 1. And if you do f of 1, you end up at this point here. So I was thinking that's maybe close to 1.5, so I just estimated at 1.4. Okay, all right, so hopefully we did well with that. Okay, next thing, we're going to do composition of functions. Okay, so to begin with on this problem, we have to start by doing g of negative 1. So start with the function on the right, plug it in and evaluate. So you'll have 3 minus 4 times negative 1 to the second. That's 3 minus 4 times 1, so that's equal to negative 1. So that means when you put this together, you can write this as f of g of negative 1, but g of negative 1 is negative 1. Okay, so now that needs to plug into the function f, so that negative 1 is going to plug in there, so we work out 2 times negative 1 minus 1, which gives an answer of negative 3. So you're doing arithmetic, but you're doing it in a certain order. Next problem, start with f of negative 1. Plug that into the function f, so do 2 times negative 1 minus 1, which is negative 3. Then we're going to write this as g of f of negative 1. And when we worked out f of negative 1, we got negative 3. So we do that. Now find the function g, 3 minus 4x squared, and evaluate that. So do 3 minus 4 times parentheses negative 3 squared, and then follow order of operations. So this would be 3 minus 4 times 9, That's 3 minus 36. So that looks like the answer on that's going to be negative 33. Okay, moving to the next problem. We want to start with h of 4, this part here. So h of 4, plug in, you're going to have square root of 4 minus 4. So that's 2 minus 4, so that evaluates as negative 2. Okay, when you put this together, we're going to write this as g bracket h of 4. And then h of 4 was negative 2. So we have g of negative 2. And now go plug this into g to work this out. So 3 minus 4, negative 2 to the second is going to be 3 minus 4 times 4. So that's 3 minus 16. So that's negative 13. Okay, and then the next problem. Go ahead and do g of 0. Plug the 0 into g, so that's 3 minus 4 times 0 squared. That'll be 3 minus 4 times 0, so that is 3. Then we're going to write this as g composed of g of 0 can be written as g bracket g of 0. G of 0 was 3, so we end up just doing g of 3. And the 3 plugs into g, so we work out 3 minus 4 times 3 to the second. So this is going to end up being, hey, stop that. Stop it. That's 3 minus 4 times 9. So that will end up being negative 33. Just a coincidence that it had the same answer as problem B. That's coincidental. Okay, so that is it. So you guys get to do these problems next, so go ahead and pause the video and then check your answers. Okay, so go ahead and check through your answers. A couple of things I wanted to mention on this is number B, you end up getting square root of 8, and whenever you have a square root, you want to simplify that. Another example of that, like if you had something like square root of 24, that can be broken down as 4 times 6. So it's 2 root 6. So whenever you have a radical, you need to be sure you simplify those. You're always looking for a perfect square that's a factor of the given number. Okay, and let's see. The other thing I wanted to mention probably is the last one. What happened on this one is you ended up with a square root of a negative number, and you can't do that, so we're not looking for imaginary numbers, excuse me. So that one's undefined. Okay, so now what I'm going to do is look at composition of functions. We're not doing anything, just evaluating. So one of the things I'll talk about is the domain also. So what I'm going to go ahead and do, whenever you do a domain, you always have to look at this function first. Now, the domain of g of x is all real numbers, okay? There's no problem with 2x minus 5. You can multiply any number by 2 and subtract 5. So we're going to go ahead and do the function composition like this. So I'm going to write this as f bracket of g of x. So the way I recommend you do this is write down the first function f. But what you want to do is you want to have, instead of putting x, you want to have a set of parentheses. And what we're going to do is we're going to plug in what g of x is. So g of x goes in here. So we get 2x minus 5 squared minus 2x minus 5. So we're going to go ahead and work that out. Okay, so a couple of things I'm going to do just kind of over here at the side is 2x minus 5 squared. You want to write that out twice in FOIL. And if you do that, you're going to have 4x squared minus 10x minus 10x plus 25. So this is going to give 4x squared minus 20x plus 25. And then distribute the negative to get minus 2x plus 5 plus 2. And then we can put this together like terms. We would get 4x squared minus 22x plus 32. So that would be the composition of that function then. Okay, now the domain, you have to do two things. You have to look at the domain of g of x. Now that was all real numbers. Then we need to figure out the domain of the answer, and that's a parabola, that's quadratic, that's all real numbers also. So we would just say all real numbers. We can write that in interval notation. Okay, better example will probably be that D. Okay, let's go to the next one. Okay, this one, we can write this as g of x. So write down what g is, which is 2 times something minus 5. And what plugs in is what g of x is. So it's the same thing. So you plug that in. Then you simplify. Okay, so the distributive property, you're going to get 4x minus 10 minus 5. So that gives 4x minus 15. Okay. Domain of that's all real numbers. Okay, and let's see. The next one, I think I thought I had intended to change. I guess not. That's a. We'll just leave the a there. So we have h of g of a. So the first thing is g of a. All that means is replace the x with an a, so that would be 2a minus 5. Okay, now write down h. H is the square root of something plus 2, and that something gets plugged in there. So you end up working this out. Okay, if you work this out, what you would have is 2a minus 3 would be the answer to that problem. Okay, and next thing on this one, when we do the domain on this, we have to start with h of x. So h of x is the square root of x plus 2. The way we find the domain of this is anything under a square root has to be 0 or bigger. So if we solve this inequality, we get x is greater than negative 2. That will be a part of the answer. Okay, that is going to be a part of the answer to the domain. Okay, so we got that. Now we're going to go ahead and do the function composition next. Okay, so we're going to write down f. F is something squared minus something plus 2. What you plug in is the h of x. So replace this with x plus 2. Place that with x plus 2, and then work this out. So if you square a square root, the square root comes off. That's no different than having something like square root of 4 squared. That's really square root of 16, so it's going to be equal to itself. So if you have the square root of x squared, that's itself. That's something you've learned before. Then we have minus the square root of x plus 2 plus 2. And then we got like terms that go together, so I'll have x plus 4 minus the square root of x plus 2. So that is actually the function composition. And then the domain we can write as set of x such that x is greater than or equal to negative 2. If that square root was something different, like square root of 4, well, x plus 4, we'd have to do a little bit more work on that. So that would be the domain of the composition of functions. Okay, all right, so if we go to the next page here, I'm going to do a couple more problems with domain. I want to work on this a little bit more. So with this one, first of all, f composed of g of x, we need to look at the domain of g of x. Okay, so the domain of that is all real numbers. So you want to start there. So the domain of g of x is all real numbers. We want to look at the domain of f of x, 1 over x minus 4. So the domain of f of x is the set of x such that x is not equal to 4. X can't be 4, it causes a 0 denominator. So you want to start by figuring those two things out. And you can write these in set, build, or interval notation, it doesn't matter. Okay, now when we do the composition, we're going to write down f, which is 1 over something minus 4. What we're plugging in is g of x. Okay, so we put in the 2x minus 5 there. Okay, so what we have is we have 1 over 2x minus 9 would be the composition of those two functions then. Okay, so what matters is this domain and this domain. That domain right there doesn't really make any difference on that. So if we look at the domain of our answer, well, look at what makes the denominator 0. If you have 2x minus 9 equals 0, you get 2x equals 9 or x equals 9 over 2. So the domain of the composition of functions would be all real numbers because we got that for g of x. So it would just be the set of x. X is a real number. And we just say x is not equal to 9 over 2. And again, you can leave off that x is a real number, and that's still okay. Okay, so that's what we have. The domain of the second function doesn't really have any bearing on anything. Okay, next thing, g composed of g of x. Well, we have to look at g of x. The domain of g of x, again, is all real numbers. So when we do this, we just write down the function 2 times something minus 5, and what plugs in is that same function. Okay, and then we work this out, so we would have 4x minus 10 minus 5, so that would end up giving you 4x minus 15. Okay, so that's how that goes. And then the domain of the result is still all real numbers. Okay, now let's see what happens on h. It gets a little bit trickier when you get to this point. So first of all, with this one, h is 2 over x squared minus 9. So h of x, we need to figure out its domain. And if we factor that, we'd have 2 over x plus 3, x minus 3. So that means the domain of h of x would be the set of all x, and x cannot be equal to 3, and it also cannot be equal to negative 3. So that will be a part of the answer to the domain of the composition. Okay, now I think this was supposed to say h there, not f. Okay, so when we put this together, write down h. So h is 2 over something squared minus 9, where you're going to plug the same function in. So that would be your function composition right there, and we need to kind of go through and algebraically simplify this. So we'd have 2 over, and so when we work this out, we're going to have 2 to the second 4. Then we'll have x squared minus 9 to the second power minus 9. And this gives you what's called a complex fraction. So I need to multiply the bottom by x squared minus 9 squared to get that to cancel out. And then I have to do the same thing to the top. Okay, so when I do this, I'm going to have 2 times x squared minus 9 squared. The bottom, you're going to have a cancellation there, leaving 4, and then minus 9 times x squared minus 9 squared. And that's good enough. I mean, you could multiply and FOIL and collect like terms if you want to, But that would be your function composition. And the domain, the only problem that you would have is you're going to have to look at this denominator, which is 4 minus 9 times x squared minus 9 squared equals 0, and you're going to have to solve this equation. So I'm going to solve this like this. So I'm going to isolate both sides. I'm going to divide by 9. When it does that, divide by 9. So that will give, let's keep doing that, 4/9 equals x squared minus 9 to the second. Then if I do the square root of both sides, I'm going to have plus or minus 2/3 equals x squared minus 9. Okay, this one's getting weird. So now I've got x squared equals 9 plus or minus 2/3. So I need to get a common denominator. I just do that. So I'm going to change this to 27 over 3 plus or minus 2/3. So I get x squared equals 29/3. And then I also get x squared equals 25/3. So you're going to have a couple of problems here on this. When you do a square root of both sides, this is a real interesting problem, then you get a couple other things. Okay, what you end up getting on this is you end up getting this. Okay, so what I need to do here is I need to do square root of both sides. And what I'll end up getting is I'll get x is equal to plus or minus square root of 29 over 3. Now over here I'll get x is equal to plus or minus square root of 25 over square root of 3, which is x equals plus minus 5 over root 3. Now this is what's weird. When you do this function composition, you got a whole bunch of things here that are that you have to throw out. So when you say this domain, you're going to say set of x, and you're going to say x cannot be equal to plus or minus 3, and then x cannot be equal to plus minus root 29 over 3, and x cannot be equal to plus minus 5 over root 3. So these things can get a little weird when you're working these things out. Okay, now I'm going to show you something on this that's kind of weird. Now you get this answer, 2 over x squared minus 9 squared, all over 4 minus 9 times x squared minus 9 squared. Now look what happens if you plug in like root 29 over 3. Let me show you. Same thing with root 25 over 3. Okay, if you worked out the details, the numerator, don't worry about it. Just, bring the numerator down. The only thing we worry about is what's going to happen to this denominator. Okay, if we do this, we get 4 minus 9 times 29 over 3 minus 9 over 1 squared. So if we get a common denominator, we'd have 4 minus 9 over 29 over 3 minus 27 over 3 squared. So that would be 4 minus 9 times 2/3 squared. So that's 4 minus 9 times 4/9. Look what happens. You get 0. You get a 0 denominator. So that's why you have to throw that out. So you've got plus minus 3 plus minus root 29 over 3 and plus minus 5 over root 3 all have to be thrown out in your domain. That one's a little weird. Okay, next one, g of x. If we do the domain of g of x, that again is 2x minus 5, so that's all real numbers. Now if we do h of g of x, we're going to write down h, which is 2 over something squared minus 9. And what we plug in is we plug in g, which is 2x minus 5. and work this out. You have 2 over, and if you FOIL this, you would have 4x squared minus 10x plus 25 minus 9. You can work out the details on that. So that's 2 over 4x squared minus 10x plus 16. Okay, so we end up getting that. Now, the only thing we have to worry about in this problem is, does anything cause this to be equal to 0? So if you take this and try to factor it, or you could take 2x minus 5 squared minus 9 equals 0 and solve that equation and see what happens. If we do this, we have 2x minus 5 squared equals 9. We do square root of both sides to get 2x minus 5 equals plus minus 3. So now we're going to have 2x minus 5 equals 3, and we're going to have 2x minus 5 equals negative 3. So this over here is going to be 2x equals 8. X equals 4 is something we have to eliminate from the domain. Over here, if I do this, I get 2x equals 2. So I have x equals 1. So on this one, we have to say the set of x such that x is not equal to 4 and x is not equal to 1. So you have to go through and you have to actually work that stuff out. Okay, so what you would find on that is if x was 4, you would have a 0 denominator. If x was 1, you'd have a 0 denominator also. You know, it's not a bad idea to plug those in and prove to yourself that that's right. Okay. All right. So let's see. I'll go through and do one other type of thing on here. And to wrap this up, so this one is like decomposing a function. So you have a inside function on this. And the inside function that we're going to use g of x. So that's x minus 8. The big function we're just going to write as x to the fourth. It's something to the fourth. So notice that f of g of x, if you do the composition, you would write down the x to the fourth, and then you would plug in the g. So you're doing this in reverse. Okay, this next problem, the inside function is that thing right there. So that's x plus 1. And then the big function would be what's left over, 2 over x to the third. Okay, so that would be how you would do a function decomposition. Pick the g of x. The inner function is what's inside of the bigger function. The big function is the whole thing, 2 over something to the third power. Okay, this one goes like this. The function inside is x squared minus 2x plus 1. The big function is absolute value of something. So we just have x like this. You can tell you're right by doing a function composition. Okay, this one, the inside function is what's under the radical. So 3x plus 2 over x minus 4. The big function is just the square root of something. So again, you're plugging that inside function in. Okay, go ahead and do these problems. Take you a minute and see if you did these right. Okay, so with this one, this is what you should have come up with. The inside function's 4 minus x squared. The big function square root of x, or cube root of x. Inside function's x over x squared minus 1. Big function is absolute value of x. All right, so that will wrap up this video. Hardest part of this for most students is domain of a composition of functions. That's the thing that you have to work on a little bit. A lot of arithmetic, a lot of algebra on this section. A lot of this college algebra review too. All right, hope this helps. Good luck.